Hello and welcome to this lab demonstration on using vSphere HA. After completing this lab video, you will be able to implement vSphere HA in a cluster. When you want to provide high availability, one of the most important principles is to implement redundancy at every possible level. What are the most common areas where we can experience failures? We can run into issues at the ESXi host level. We may have problems with virtual machines, with data store accessibility. There can be issues with the network, maybe a complete network failure, or just one network interface card. There can be problems with applications running on virtual machines, and many more. vSphere HA can address most of these issues and provide rapid recovery from outages. It can restart virtual machines on another ESXi host when there is a host failure. It can restart the virtual machine when it stops receiving heartbeats from the virtual machine. In case of lost data store accessibility, it can restart virtual machines on another host that still has access to the data store. It can restart virtual machines on other ESXi hosts when a host becomes isolated on management or vSAN networks. Long story short, vSphere HA can do lots of things to keep virtual machine downtime to a minimum. However, implementing vSphere HA in complex environments will require quite some preparation work. There are lots of things that you will have to consider. Which type of failures and how many concurrent failures do you want to be able to cope with? For example, in a cluster with 8 ESXi hosts, how many hosts are allowed to fail so that all virtual machines can run on the remaining hosts with acceptable performance? Are you using resource reservations, and are you willing to set aside resources and prevent them to be reserved during normal operation so that they are kept available for virtual machines of other hosts in case that these hosts fail? How much virtual machine performance degradation can you accept in case of host failures? What if vSphere HA cannot find enough resources for a resource-intensive virtual machine on any remaining host in the cluster, but you could make these resources available on one ESXi host by moving one or more smaller virtual machines to other ESXi hosts, because these other ESXi hosts do have enough resources to satisfy the requirements of the lighter virtual machines? Do you need to control the order in which virtual machines are restarted on other ESXi hosts? Do you have the need to run certain virtual machines on the same ESXi host so that they must not be distributed across multiple hosts? You see, there are lots of things to consider when implementing vSphere HA in complex environments. In this lab, we will focus on responding to ESXi host failures by starting virtual machines on any other ESXi hosts, on providing redundancy for the management network, and we will configure the cluster to give us a warning when the performance of the virtual machines currently running in the cluster would fall below a configurable threshold when there are as many host failures as we are willing to tolerate. The lab will not cover more advanced features, so make sure that you dig deeper into this topic when you have to implement vSphere HA in a production environment that has more complicated requirements. To benefit most from this lab, you should know the vSphere client user interface, and you should be familiar with ESXi host networking, vSphere vMotion, vSphere DRS, and vSphere resource management features, such as reservations. In the first task of this lab exercise, we will enable vSphere HA in a cluster. Then we will view information about the vSphere HA cluster. We will check which ESXi host is the master host and verify that all virtual machines in the cluster are protected by vSphere HA. We will also check which data stores are used to monitor heartbeats. And we will also check for HA-related issues and find that there is no redundancy for the management network. In the next task, we will enable management services on an additional VM kernel adapter to create network management redundancy. Then we simulate a host failure to test vSphere HA functionality. In task 5, we will examine whether there are CPU or memory reservations in the cluster. And in the final task of the lab, we will enable vSphere DRS and look at the available HA admission control options and configure the percentage of performance degradation we want to tolerate. Then we will verify that we receive a warning when the cluster doesn't have enough available resources to prevent performance from falling below the configured threshold in the event of a host failure. I'm sure I provided you enough good reasons to watch the following video on using vSphere HA. Now let's get started. We want to perform the configuration on vCenter server SA VCSA01. So the first step is to connect to this server. Then we log in as administrator at vSphere.local. In the first task, we will enable vSphere HA on the ICM Compute 01 cluster. From the menu drop-down menu, we have to go to the Hosts and Clusters view. Then we select the ICM Compute cluster. In the right pane, we click the Configure tab, and under Services, we select vSphere Availability. We can see that vSphere High Availability is turned off. So we click Edit. And now we enable vSphere High Availability by clicking here. We can have a look at the host monitoring options that are selected by default. So in the event of a host failure, our response is to restart VMs on another host. If we identify host isolation, then there is no response configured. In case of data store issues, there are two of them. One is PDL. So the first data store option that we have, data store with PDL. What does PDL mean? It means permanent device loss. We enter this state if we were not able to reach the data store for 2.5 minutes. During these 2.5 minutes, we would have the data store with APD condition. APD means all path down. So we can configure these two events separately. If we encounter the permanent device loss, then we power off and restart VMs. When we identify the all path down event, then we power off and restart VMs. What does that mean? Well, the all path down is considered to be a recoverable event. So when we identify that we lost connection to the data store, we may power off the VMs, but if the connection is restored, then we restart the VMs. And VM monitoring would mean that we are monitoring the heartbeats of our virtual machines. So we keep the default settings here. So all we have to do is click OK. And we can see that the screen changed and it says vSphere HA is turned on. In the recent tasks at the bottom of the screen, we can see that the vSphere HA agent is installed on the ESXi hosts that are in the cluster. That's SA ESXi01 and SA ESXi02. Now we see an information here that says waiting for cluster election to complete. This is where the master server is elected. And we can see that the status of the task now is completed. So it seems that we are done. Now where vSphere HA is enabled, we can move on to the next task. And in this task, we will view information about the vSphere HA cluster and check if vSphere reports any HA related issues. So we still have our cluster selected in the navigator pane. And now in the right pane, we click the Monitor tab. And under vSphere HA, we click Summary. And what we can see is which of our ESXi hosts has been elected as the master. In our case, it is ESXi host SA ESXi 02. And we see the number of hosts that are connected to the master. In our lab, this is 1 because we have 2 ESXi hosts in this cluster. Actually, let me expand the cluster in the navigator pane, then we can see our ESXi hosts. Also note that we have 3 virtual machines that are currently running in the cluster. That's Win1002, Win1004 and Win1006. And in the summary in the right pane over here, under virtual machines, we can see that it says there are 3 protected virtual machines and 0 unprotected virtual machines. This refers to the virtual machines that we have running in the cluster, and we can see that all of them are protected. Now let's select Heartbeat under vSphere HA. The HA functionality can utilize data stores for heart beating, and this is done in our case on 2 data stores. On the data store called Shared VMFS and the iSCSI data store. We can see that 2 hosts are mounting these data stores. Data stores that have all the ESXi hosts that are a member of the cluster connected are automatically selected for heart beating. Now let's have a look at configuration issues under vSphere HA. We can ignore that SSH is enabled on one of the ESXi hosts that's not HA related. But what we see is that both ESXi hosts have no management network redundancy. That's a single point of failure. So let's solve this problem in the next task. At the moment, each of our ESXi hosts has 3 VM kernel adapters. One that is used for management, that's the one that was reported as a single point of failure. One that is used to access an iSCSI data store, and one that is used for vMotion. In the next steps, we will simply add the management service to the VM kernel adapter that is currently used exclusively for vMotion. As a result, the management service will run on 2 VM kernel adapters. These 2 adapters are connected to different vSwitches, and the vSwitches are attached to different physical adapters. That means that we will then have network redundancy for the management service. So in the navigation pane, we select SA ESXi 01, our first ESXi host, and then we click the Configure tab. Under Networking, VM kernel adapters, we now select the device VMK2, and we can see that the enabled services at the moment only shows vMotion. So while we have the adapter selected, we click Edit. We see the list of enabled services, and now we activate the checkbox for management. And you can see down here that now management got added to the list of enabled services. Now let's do the same for the second ESXi host. We select the adapter that is currently used for vMotion only. We click Edit. We check Management, and we click OK. What we have to do to make this change effective is in the navigation pane we right-click the ESXi host and we select Reconfigure for vSphere HA. And again, we have to do this on both of our ESXi hosts. We can see tasks in the recent tasks pane, and we wait for these to finish. Now let's see if our configuration issues are resolved. So we select our cluster, ICM Compute 01, and under vSphere HA configuration issues, we see that the previously reported issues about the lack of network redundancy are not shown anymore. We only have the message left that SSH is enabled on ESXi host SA ESXi02. So we fixed the host management network redundancy issue. In the next task, we will test vSphere HA functionality. First, we will identify which ESXi host acts as the master host. Then we will make sure that virtual machines are running on the master host, and we will verify that all virtual machines are protected by vSphere HA. Then we will simulate a failure of the master host by rebooting the host without putting it in maintenance mode. And finally, we will verify that virtual machines are restarted on the remaining host in the cluster and that the remaining host is the new master host. So we select our cluster, actually it is already selected in this case, and under vSphere HA, we are in the Monitor tab, we click Summary, and just to be sure, let's refresh the screen. And now we see the current master, which is ESXi host SA ESXi02. Now let's verify that this ESXi host contains at least one virtual machine that is currently running. So we select the ESXi host in the navigator pane, and then in the right pane, we click the VMs tab. And we can see that two virtual machines are running on this ESXi host. It's Win1004 and Win1006. Now let's go back to the cluster. And in the Monitor tab, in the Summary, we want to make sure that all the virtual machines that are running in the cluster, there are 3 of them, are still protected by vSphere HA. And they are. Now we will simulate a host failure. And we do that by rebooting the master host in the cluster. So we right-click the ESXi host, we select Power, and then we click Reboot. We are rebooting an ESXi host, and under normal circumstances, you wouldn't do that without putting the host in maintenance mode. Since we want to simulate a failure, we will not put the host in maintenance mode, and we will reboot the host. Let's document this. So for the reason of the reboot operation, we enter vSphere HA. Then we click OK. Now we want to view the events that occur in the cluster. So we select the cluster in the navigation pane. And in the Monitor tab, under Tasks and Events, we select Events. The events are sorted by time. So the latest event is on top, And when we look at the third entry, then we see that the HA availability state of the host SA-ESXi01 in our cluster changed to master. Why is that? Well, because the previous master, SA-ESXi02, is currently rebooting, so we lost our master and had to elect a new one. If we go further down, actually here we see the task to initiate the host reboot. So after this event, the problems from the perspective of HA started. So we see that an election started, that the vCenter server is disconnected from the master HA agent running on host SA-ESXi02. During the election, the state of our other host SA-ESXi01 changed. First it was slave, and later that ESXi host became master. So we have several messages that indicate that there was a problem. And for example, here we see that the HA availability state of our ESXi host SA-ESXi02 changed to unreachable. Then we see message regarding the election of SA-ESXi01 becoming the new master. Now let's have a look at our ESXi host SA-ESXi02 that we rebooted. And when we look at the list of VMs, previously we saw 2 VMs here that were running. We see that currently no virtual machines are running on this ESXi host. But the VMs are still running. So when we have a look at these VMs, Win1004 for example, we see that it is now running on ESXi host SA-ESXi01. And the same applies to the other virtual machine, Win1006. These 2 virtual machines were previously running on our master host SA-ESXi02. And because of vSphere HA, when host SA-ESXi02 went down, the virtual machines were started on one of the remaining hosts in the cluster. In our case, there is only one other host, SA-ESXi01, and that's why they were started on this ESXi host. Now let's go to our cluster in the navigation pane. In the Monitor tab, under vSphere HA, we want to click Summary. And we see that the new master is SA-ESXi01. We also see that the number of hosts connected to this master is 1. That indicates that our ESXi host SA-ESXi02 finished the reboot and it joined the cluster again. So both hosts are up and running. vSphere High Availability worked as expected. Virtual machines that were initially running on the host that failed are now running on the remaining host of the cluster. In our lab, where we only run a few virtual machines that do not use lots of resources, the remaining host can easily handle the load so that the performance of the virtual machines is not degraded. In a production network, things might be different. Therefore, in the following tasks, we will look at the features of vSphere HA admission control. First, we will view the vSphere HA cluster resource usage and check if there are reservations. This information will be relevant for the final task, configuring admission control options. In the navigation pane, we select our cluster. Actually, it is already selected. So in the Monitor tab of our cluster, under Resource Allocation, we select CPU. And now we want to have a look whether there are any reservations. And we can see that the used reservations are 0. The total reservation capacity would be 427 gigahertz. So all of this is available. No reservations are configured for the CPU. And when we look at the memory reservations, we can see that none of the virtual machines have any memory reservations. We do see 154 megabyte of memory being reserved here, but that's not reserved by virtual machines, but that's reserved for the ESXi host itself. As you can see down here, the virtual machines all have a reservation of 0. We now know that our virtual machines have neither CPU nor memory reservations set. In the last task of the lab, we will examine vSphere HA admission control options. Admission control features rely on vSphere DRS. Therefore, we will first enable DRS on the ICM Compute 01 cluster. Then we will choose the admission control option to configure the percentage of performance degradation that we are willing to tolerate in the event of a host failure. Remember that we did not configure any CPU or memory reservations. Therefore, there is no guarantee that our virtual machines will find sufficient resources in the cluster when one or more hosts fail. By setting the accepted resource degradation, we at least get an informational message when the load in the cluster reaches a level where the desired performance could not be provided in the event of a host failure. We will verify this as follows. First, we will generate heavy CPU load on virtual machine Win1002. Then we will check if we see the message that the current resource utilization is too high to satisfy the demand for the required failover resources. Finally, we will reduce the load on virtual machine Win1002 and verify that the message is no longer displayed. So the first thing is to enable DRS on the HA-enabled cluster. In the navigation pane, we right-click ICM Compute 01 and select Settings. In the right pane, under Services, we select vSphere DRS, which is currently selected, and we see that DRS is turned off, so we click Edit on the right. And now we use that toggle switch here to enable vSphere DRS. We want to set the automation level to fully automated, and we click OK. Now we want to configure the percentage of resource degradation to tolerate. Under Services, we select vSphere Availability. We see that vSphere HA is turned on, and we click Edit. We have been at this tab already when we enabled HA, but now we click the Admission Control tab. At the top, we see the number of hosts failures that we want to tolerate. If more hosts fail, then we would not expect vSphere HA to handle the situation. The default is 1, so we want to be able to provide high availability features when up to 1 ESXi host fails. The next parameter applies only to a cluster that has virtual machine resource reservations. In such a case, to ensure that the virtual machines find their reserved resources, vSphere HA must prevent all resources from being reserved under normal operation. So if the number of hosts that we configured up here at the first parameter fail, their reservable resources must be available on the remaining hosts of the cluster. Therefore, vSphere HA's admission control function blocks a certain capacity of resources for this purpose. And the second parameter defines how this blocked failover capacity is calculated. There are three options. The currently selected one, that's the default value, is based on percentage. Another one is called slot policy. This is an older method, and it is less efficient than the newer percentage-based method. And then we have the option to use dedicated failover hosts. In most cases, you will leave this parameter at its default value. The same applies to the override option that we see below. In our case, all of these settings do not apply anyway, because we do not have resource reservations. However, what we can and will do is to set the parameter down here. It specifies the percentage of performance degradation that our VMs should tolerate. What does that mean in our lab? vSphere HA will monitor the CPU load in the cluster. It knows how many hosts are allowed to fail because of the setting on the top. In our case, it's one host. And based on the percentage of performance degradation we are willing to accept, vSphere HA can estimate how much CPU the virtual machines can sacrifice to achieve the desired performance. If the remaining ESXi hosts do not have enough CPU to satisfy the reduced CPU demand, a message is displayed indicating that the required resources cannot be provisioned. The default value for the degradation is 100%, which means that no warning is displayed. We do not want to accept any performance degradation, so we change the value to 0. That means that we will get the warning message when the remaining ESXi hosts do not have as much CPU available as the VMs that reside on potentially failing ESXi hosts are currently consuming. Now we click OK. Now we will generate high CPU load on one of the virtual machines, on Win1002. So in the navigation pane, we select this virtual machine, and in the right pane, in the Summary tab, we launch a web console. On the desktop of the virtual machine, we have a script that we can execute. We open it with a command prompt. And this script performs very CPU-intensive sine computations. So we will have heavy load on this virtual machine. And remember, we configured vSphere HA so that we do not want to tolerate any degradation of VM performance. So let's go back to our vSphere client. We select our cluster. We go to the Summary tab. Let me scroll to the top of this tab. As you can see, the message is displayed, and this message tells us that the running VM's utilization cannot satisfy the configured failover resources on the cluster. So this tells us that if we had a failure now, we would be in trouble because we could not start the virtual machine on the remaining ESXi hosts and achieve the desired performance. Now let's stop this condition. Let's go back to our virtual machine. And now we close this script. As a result, the load on this virtual machine will decrease. And once this has been detected, the message should disappear from this view here. So we will have to wait a little bit. And let's refresh the screen. We can see that the high load message for the virtual machine itself is already gone, and we also expect this message here to disappear. As you can see, the message now disappeared. This indicates that we're not having these performance issues anymore. Note that it can take quite a while until these messages appear or disappear. It may take a few minutes for the messages to change. Congratulations! You have completed the Using vSphere HA lab demonstration video. In the first task of this lab, we enabled vSphere HA in a cluster. Then we viewed information about the vSphere HA cluster. We identified the master host, verified that all virtual machines in the cluster are protected, and we identified the data stores that are used to monitor heartbeats. Then we viewed vSphere HA configuration issues and saw a message indicating that there is no redundancy for the management network. In the next task, we fixed this problem by enabling the management service on an additional VM kernel adapter. Then we tested vSphere HA functionality by simulating a host failure. We saw that the virtual machines that were initially running on the host that went down were started on the other host of the cluster. In the next task, we viewed vSphere HA cluster resource usage. In the next task, we viewed vSphere HA cluster resource usage and reservations. And in the final task, we configured vSphere HA so that we get a message when virtual machines would experience performance degradation in the event of a host failure. We did that by setting the percentage of tolerated resource degradation to 0%. Then we created heavy load on a virtual machine and verified that the message was shown. You now know how to implement basic vSphere HA features in a cluster. Note that there are a few more HA features to explore that were not included in this lab. When you plan to implement vSphere HA in your environment, you should first carefully analyze your needs and then extensively test the desired features in a lab environment before you roll them out to production. Thank you for watching this lab demonstration video. I hope the knowledge acquired here will help you with your daily job assignments, and good luck as you continue your journey in VMware world.